Hello, Flat Earth researchers, debaters, and debunkers. I'd like to make a correction or clarification about this particular point in the video that I put out yesterday, titled Flat Earth versus How Surveyors See Imaginary Curvature. This is what was pointed out to me by the man here and a few other people. He said here that you're trying to convince us at 16 minutes that the same size person will be below the photographer's line of sight in the distance, and quotes me as saying the person would appear to be down here in the distance. Are you serious? And quotes me again as saying this is simply how it works, and goes on to say that you are so confused that I really don't know what to begin. I think he meant where to begin, but it doesn't matter. I get the point. And yeah, okay, I should go and clarify this or make the correction. Okay, so I definitely agree that let's just grab this person. This person's height doesn't change, and as long as they go away from the observer on a flat surface, then of course they will remain at eye level for the observer. Yeah. But of course, in the eyes of the observer, they will appear to be smaller. So yes, I should illustrate that like this, to represent that particular point, that when we are referring to eye level, someone of the same height goes off into the distance and they will remain at eye level. But what I should maybe do is fade that out a bit to further illustrate the point here, that what we're talking about here is concepts, this kind of external reference frame that has been created from calculations and measurements made from the observation. So this is just an illustration of what's seen by the observer. And I suppose one of the main points I was making there is that while anything at eye level remains at eye level, what we have as things go off into the distance is anything above or below eye level we will see a change in the angle. So using this eye level as a reference point, which is a measured and calculated height above the flat surface, we have this angle to anything below eye level like this. But of course, as that person goes off into the distance, you'll have this change in the angle from that reference point of the eye level. And so we get these degrees. And of course, the degrees that we get are also in reference to this plumb line, or various plumb lines, but this vertical here. So it's just playing around with angles. And of course, the angles are always going to be somewhere between 90, 180, and 360 degrees. So it doesn't matter how we illustrate this, whether we use tangent lines, triangles, or even squares and spheres, we still end up playing with the same thing, and that is these angles which have a sum of 90 or 180 or 360 degrees, whatever it may be, for a conceptual illustration. And that's what we're facing with all of this when it comes to the flat earth and the globe. We are talking about concepts that are derived or illustrated from observations and the angles of those observations. The important point that I was trying to make in the previous video was that with surveying, we're talking about tangible objects. And so, using theodolites to talk about the horizon is a straw man argument. It's irrelevant because the horizon is not tangible. Of course, in the globe concept, the horizon is considered to be something tangible. It's, this part of this geometric surface. But that is really just a conversion of perspective into this curve, which can be illustrated because we are playing around with angles. That we'll kind of we'll have a look at that a little bit more now. What's interesting though about this way of illustrating it is we kind of get this optical illusion, which it's really going to depend on how you perceive it. What's important to point out here is that the blue lines and this person in the distance, which have now kind of faded a bit, and the red line of the eye level, are all conceptual. Yeah, we could take this as an illustration of looking at this scene from a perpendicular point of view. We're looking at the photographer taking a picture of the subject, but at the same time, by putting these lines in, what I've ended up creating is, let me just bring the opacity back up again. Yeah, what I've ended up creating here is something that can be looked at in a couple of different ways. A bit like this image here. You've probably seen this. You either see this as a vase, a black vase, or two faces looking at each other, and we've got this side-on view of these two faces. You're in the mind's eye, you see it as either one or the other. You understand that you're seeing two different things here, but you can only ever see it as one thing at a time, and it really is going to depend on how your brain decides to see it. And so the same here, what we've ended up doing is creating this illustration where we can look at this as a side-on view with the photographer and the subject, but then and then understand that the blue lines and the red line and this person in the distance is just illustrating what is seen, or the changes that are seen over distance. But at the same time, we can also look at this as a scene that we are seeing from an angle of 45 degrees. So it's funny, when you get this kind of 45 degrees, this is like a magical number in terms of perspective that is then converted into the geometry that's used to illustrate these concepts. This is maybe do you see what I mean? So you now have this blue line can now represent a surface, and so we have what might appear to be this three-dimensional drawing that it's got depth now, because we've got this visual representation of someone in the distance and appearing smaller, and it's all in relation to these lines. So it could be a scene where we're looking at someone against a wall, and we're looking at this scene from an angle of about 45 degrees. Yeah, or we can just understand that it's a representation of this perpendicular view, and then we're just kind of making some other illustrations to illustrate the point. Yeah, so it can be confusing in that respect. You suddenly get this optical illusion, just like these vases, where you can see it as one way or another. Yeah, this kind of side-on view, or a more of a 45-degree view. So let's just have a look at that. It's quite interesting, this 45-degree angle. Again, just keep in mind that we are looking at a scene that is, the observer here, this girl looking at the building, isn't seeing herself like this, but we are seeing it. We've illustrated what she's seeing like this. And of course, it was, some people misunderstood that I was saying that surveying doesn't work. Of course it works, but it works with tangible objects, not the horizon. The eye level is something that's measured. The height off the ground is definitely used as part of the equations. And what you have here, of course, is something we're all taught at school, is that this person standing at a distance away from the building that is equal to the height of the building above their eye level gives you these angles of 90 degrees here and 45 and 45 degrees here. So you end up with a total of angles that add up to 180 degrees. And so, of course, we know that 180 degrees is also a semicircle. You put these two triangles together, you can get a square, and you can get 360 degrees. Or you can get, a sphere that is also 360 degrees. Again, they're all concepts, and it's all based on the angles of converting those angles made from an observation to create this scene and create this concept of where everything is. And of course, you can imagine that this building, for example, and another building is on a spherical Earth, And if you conceptualize it like that, then these buildings will not be parallel to each other. In reality, they are, but we can conceptualize it as being, the converging at some point with imaginary lines towards the center of a spherical Earth, or diverging. We can conceptualize all of that, but in the reality, in the real world, the physical world, we are measuring tangible objects. And as far as surveying in this kind of respect goes, it's all very fine. It works. There's no contest. There's no disagreement that this all works. But what has to be understood is that it's all just concepts or illustrations that convert the angles that we see. So just going back to that again, the angles that we are representing here will again always come around to this reference point of the observer's eye level, and it's that that's used. But of course, what we have here is this apparent convergence, of the surface and the sky and the distance, and of course the observer's height can change and what have you. But hopefully that kind of clarifies the point there, that I do agree definitely that something that goes away from the observer at the same height will remain at that observer's eye level, but anything above or below that eye level will of course change, and those angles that we then get from those observations can then be illustrated in this way, and we can illustrate them as circles or triangles or squares or whatever. The whole point is that we end up playing around with geometry. We've converted perspective and the angles of perspective into this imagined triangle or imagined sphere, or it's basically, it's arbitrary. It can be conceptualized in a variety of different ways. But the fact is that when we make an observation, things will appear smaller and things will appear closer to the eye level as they go off into the distance. And so, you do get these differences in the angles, and that's what's used to then conceptualize everything. So the main point of the previous video is to say that theodolites and the other tools that are used are for measuring tangible objects. Any arguments that refer to the horizon are irrelevant, because as I said, the horizon is created wherever the observer's eye level is, so the horizon isn't used as a reference point. It is the height above the surface that's used as a reference point, and of course, distance will make a difference to the angles that are measured for anything that's above or below the eye level as you go off, and then you can create your curvature, because we're not talking about distances necessarily. We're talking about ratios of angles, and so this all becomes very, very flexible and allows us to conceptualize it in a variety of different ways. But we have to understand, that we're not seeing these scenes like this. We are converting what we see through a camera or a theodolite into this scene. So of course, in an illustration like this, then the observer is illustrated in a way that's relative to the height of the building. But of course, how that building will appear to the observer will depend on that observer's distance. So they get further away and you lose this 45-degree angle, and then of course you get this apparent shrinkage down towards the eye level. So eventually you get to the point where that building is just part of the horizon when that person is far enough away. So there's no measurement that you can make. But the point here is that you when you get that 45 degrees, you know that you've gotten as far away from the object as it is high, and it works absolutely fine. You can, there's another illustration here where the formula works, but of course all we're doing is illustrating the height relative to the observer and what the observer sees or measures through a theodolite. It's all just concepts. But of course, here you can see that it would usually be done on a flat surface, but then you can convert all those angles into this imaginary curved surface as well. And you can imagine that there will be this convergence and divergence of 2 points that are that are physically parallel, but you can imagine them as being not quite parallel on a spherical Earth. It's all about concepts. Okay, so yeah, hopefully that clarifies a little bit more what's going on there, and also reinforces the point that all of this is about perception. And as we know, we are easily deceived or quite capable of perceiving things in a variety of different ways. All right. Thanks very much.
Click subscribe and the bell icon if you'd like to receive notifications of new videos from Phuket Word.